Hi, we're going to discuss special right triangles. So there are two types of right triangles that we recognize in geometry that are considered to be special because of a special relationship that you can establish between the sides. So let's start with a 45-45-90 triangle. So what do we need to know? This is an isosceles right triangle, which means the legs are going to be congruent. So the question is, how long is the hypotenuse there? Well, the hypotenuse is going to be determined by, let me call it C. It's going to be determined by the Pythagorean theorem. So one leg squared plus the other leg squared equals hypotenuse squared. So C squared equals 2x squared. And I'm going to take the square root of that. So C is going to be x square root of 2. So this side is going to be x square root of 2. So if I know a leg, the length of a leg in a 45-45-90 triangle, I automatically know the other leg, obviously, because they're congruent, and the hypotenuse will be square root of 2 times the length of the leg. Okay? So let's try some problems. Find the lengths of all missing sides. So this is a 45-45-90 triangle. You have a 90 and a 45. Obviously the third angle will be 45 as well. So what do we know? If this side is 8, this side is going to be 8 as well. What about this? Well, you multiply the length of a leg by square root of 2. So 8 square root of 2. And you are done. Find the lengths of all the missing sides. So here we have a 45-45-90 triangle, but we're given the length of the hypotenuse. So let's think about this. In this problem, we knew the length of the leg, and we multiplied that by square root of 2 to get the length of the hypotenuse. So if I know the length of the hypotenuse, I'm going to be dividing by the square root of 2. So for example, if I want to find by, I'm going to do 10 divided by the square root of 2. Now we need to rationalize it, of course. Don't leave it like that and not put the square root on the bottom. So you're going to multiply top and the bottom by the square root of 2. Right? And that's going to give us 10 square root of 2 divided by 2. And that's actually going to give us 5 square root of 2. So by is 5 square root of 2. And BO is going to be 5 square root of 2 as well, since it's an isosceles triangle. Alright, 30-60-90 triangle. So what typically is done is you can get the relationship in the 30-60-90 triangle by using an equilateral triangle and cut it in half. So when I cut it in half, what happens here is this is going to be 30, this 60, and this is 90 obviously. If this side is x and this is x, then this is the whole side here, which all three sides are congruent. This side is going to be 2 times x, right? Because x plus x is 2x. What is the length of this side? Well, let's call it h, and let's set up the Pythagorean theorem. So what do we know? We know that x squared plus h squared equals 2x squared. That means x squared plus h squared equals 4x squared. And we're trying to solve it for h. So h squared equals 3x squared. And that means h equals x square root of 3. So this here is going to be x times the square root of 3. So let me summarize this. If you have a 30-60-90 triangle, if you consider the shorter leg, the one that's opposite 30-degree angle, as x, the other leg is going to be x times the square root of 3, and the hypotenuse will be 2 times x. This is the relationship between the sides. And let's go ahead and take a look at some problems. So we have this triangle, we have this side, this angle is 30, we know the length of the hypotenuse. So what do we know? We know that the leg that's opposite 30-degree angle, if you double that, you're going to get the length of the hypotenuse, right? So that means I can go back there by dividing it by 2. So BA is going to be 16 divided by 2, which is 8. And then to find AC, you need to take the shorter leg and multiply it by the square root of 3. So AC is going to be 8 square root of 3. Let's take a look at this problem. Trying to find the lengths of all the missing sides. So we have 60, that angle is obviously 30. So this one's a little trickier because you're given the longer leg and everything is usually tied through the shorter leg. So how do we calculate the length of the longer leg? You take the shorter leg, multiply it by the square root of 3, right? So to go back there, I need to divide by the square root of 3. So x then is going to be 12 divided by the square root of 3. So I'm going to need to rationalize it. So multiply by the square root of 3, multiply by the square root of 3. That's going to give us 12 square root of 3 divided by 3. And that's going to become 4 square root of 3. So x here is 4 square root of 3. What about y? Well, to get y, you take the shorter leg, because this is the hypotenuse, you take the shorter leg and double it. So y is going to be 2 times 4 square root of 3, which is going to be 8 square root of 3. So this here is going to be 8 square root of 3. Okay. I have a couple more examples. So we have an isosceles triangle in example 5, and we're trying to find the length of BD, which is essentially the altitude of this triangle. So yes, this whole triangle is not 30, 60, 90, but this is. Okay. So if we know this, the hypotenuse is 12, we would know that the shorter leg is going to be half of that, which means this is 6. And to find BD, you take the shorter leg and multiply it by the square root of 3. So 6 square root of 3. And we're done. We're given this square, and we want to find the length of its diagonal. So as you probably remember from what you learned about triangles, if this is square, all sides are going to be 3, right? But right here, this is a right triangle, which is an isosceles right triangle, so that's 45, 45, 90. And that means we can use what we know about that, and if I call this x, then x is going to equal 3 times the square root of 2, and that's it. I hope this helps.